Anybody to invite currently. But
we're live.
All right, cool. Hey everybody, what's up? It's Papa Bale. Mike does.
Playing some music here.
Awesome. You can see it in the background spinning right there. That's Bedini SSG. Ha. Yeah. Right. Well,
I don't know why it's got a circle around your picture.
I had a circle around yours too. Maybe it's Is there a way to like get my phone? We did this before. My phone feed, like have my mobile, and I can go over there and take a
look.
Yeah,
I'll just put the invite link and you click on it from your phone.
Okay.
If you can get to Discord on your phone.
Yeah, I can do that.
So I guess I'll put the invite link in the chat. Hey, Christopher Houghton. Hello, hello.
Hello. All right, so I need to go into the Discord on my computer to find out exactly this is.
Oh, go to the stream and click on the link. I put it in there in the comments.
Okay. There you go. Wait. You put it in StreamYard?
On the YouTube live in the comments. Link.
Oh. Yeah, I don't have it on my phone yet. Let me get it on my phone. There we go.
Actually, they're right here. So what did you want to talk about?
You want to put it in the Discord?
The link? Yeah.
Yeah.
It's in there.
All right, there we go. Oh, wait a minute. All right, let me go to the Discord and all right. All right, now remember how to swap the camera from your face to the
swap the camera.
Yeah.
What do you mean, in StreamYard?
Yeah. Is the gear camera?
No, I'm not good with those phones.
All right, I'm in.
Oh, there you go. You can mute the mic on the phone, I think, or depends how it goes.
All right, yeah. Wow.
Or mute your headphones or something.
Yeah, I'm gonna do that. All right, there we go.
Yeah. Can you hear me?
All right. Now, I want to show you guys what I'm doing here, and I want to talk about what I have and what I need. So let's look at.
Tech house beats, they move house souls.
Can you hear me through the phone?
Yeah, I can hear you. I just don't know how to like switch from my selfie to my camera.
It's the clockwise arrow, bottom right, I think.
More?
It's like a circular arrow.
No, I don't see a circular arrow. And then you hit cam and it goes on. Yeah, the cam just turns it on and off. There we go. I don't know. Maybe I'll just turn it around. How about that? Just turn my phone around.
You'll be able to see on the computer what your phone is looking at.
Yeah, you can see it on the computer what I'm looking at? Oh, that's not what I'm looking at. I'm not trying to look at me.
No, turn the phone around at what you want to show. There. Yeah.
All right, here we go.
And look at the computer to see what the phone is seeing. Yeah, we can see. I don't know why it's a circle around it.
Wow. Okay, I wish I knew how to change that.
I think it's in my StreamYard settings. Let me see here.
All right. I'm gonna... Yeah, so basically I want to figure out I want to figure this out, and then I want to figure out what I need to do this, and you're the guy to talk to, really, to figure out how to do this. So just technical difficulties. You want to ask the chat?
Give me a second. I'm doing something and getting rid of that circle around the crop solo layout to show background. No. Crop layout.
It might be because I'm logged in twice.
No, I think I.
No, okay.
Let me see here. Layout to show that crop layout. New spotlight layout. That's what I think it is. No.
Here we go. There it is. We got it. All right.
No.
Yeah, there we go. All right.
Okay.
So let's get our meter readings real quick. Find out, like, from that what we need exactly. All right, this is the drive battery right here. It's going at 1218, 1,800, and it's, well, that's the primary, and then the charge battery is up to 1271, which is nice. That's moving really fast, though, for how low the battery is. I think it is, anyway.
Yeah, I think it when the battery gets charged up, it moves slower because there's nowhere for the charge to go.
I get what you're saying.
Because is that the Bedini circuit you're running there? The SG?
Yeah, the SSG right here, with gen mode.
Right.
So it's
So
got gen mode.
I think when the battery fills up, the the flyback has nowhere to go, so it impedes the drive coil instead, because the flyback has to get out of the drive coil. If it stays in there, it acts like lens. So in that respect, it slows down the wheel.
Oh, I got you.
That's what I think is going on anyway.
It looks like it's going pretty slow, doesn't it?
Yeah, that's a nice. You printed that on the 3D printer, those rotors?
Yeah. Yep.
Nice.
It's going like gotta be going close to like 700 right now. So I mean, like, it is going slow in comparison to other ones, but I think for what it is, it's going pretty fast. It's got a 10 millimeter shaft. It's running on a Bedini SSG. My pot is a little out of date, but it works. I discovered that it works, so that's good. It's a 16 gauge coil for the drive, so it's a fat wire, and 26 gauge trigger.
What's the trigger again?
26.
26?
Yep.
And the drive was what? 16?
16.
So yeah, you have a 26. I think that's what Bedini uses, is a 26 and a 22 or
It's
something.
a really good wire to use as a trigger. It's really good.
Yeah. If you go thinner on the gauge for the trigger, you'll get an easier trigger, but it'll be less duty cycle, less current. It'll trigger easier though, because the voltage will get through a lot higher voltage with less current.
Yeah. I have to spin it less hard on the torque there.
Right. The trigger, the thinner the gauge, the less current you'll be able to put into the transistor.
Yeah, but I only need to, like, for the trigger, the base, it only needs, like, what is it, 0.5 of a volt or less, or like, or is it 5 volts?
2 volts.
2 volts? Okay. So I'm easily doing 2 volts here, like, well, it's not a MOSFET, so it's a, I'm not sure exactly what I'm pulling for the trigger coil, but I don't have to, like, put any effort into spinning it to get it started, you know?
How many feet of 26 is it? More than 150 feet?
It's less. It's
Less than that.
Yeah, it's
80 feet. Well, that depends on your magnets, how close they are to the trigger winding.
180 turns of 16 gauge.
Well, that's the drive winding. I was asking about the trigger winding. How many?
Same length.
Same length.
Yeah.
But you don't know the length though. You know the turns.
Yeah, the turns. Same amount of turns.
Was it from a spool?
2 spools. Yeah.
You don't know how many feet was in that spool?
Well, there wasn't a whole spool.
Half a spool, or?
I'm not exactly sure. It's been around for a while, but I know that
Hey,
I made it as part of a set. And it might be 280 turns. It could have been a whole spool now that I think about it. Because I got these coils here. They're single file 16 gauge coils that are for extensions for this very coil that I got over there. So you just line those other coils up with the magnet on your rotor, and you get a little torque boost. And you only need the one trigger as long as you line them up. That's what I figured out. But, you know, that's a whole nother project, man. That's something else. Got off track there.
Yeah.
So I turned the knob a little bit. Remember how it was low? If you can see that. I can't see it. But it went up. And that's the input voltage. Or the battery of the primary. That's the primary battery voltage. And it went up. Like
Right.
to just a little bit from when I tweaked it.
This is the 2-battery system with Bedini, right?
Yeah.
And the drive battery should be dropping while the charge battery is rising.
The drive battery is dropping at a phenomenally slow rate, but yes, you're absolutely right. And then, you know, you can make it rise if you want a little bit, but it'll continuously drop. Absolutely.
What is the resistance on your potentiometer? Do you know how many ohms you got?
1,000 ohms, 1K.
Wow. So 1K, yeah, that's pretty good. You're using a gauge 20 drive.
16.
16. Yeah.
16.
So you're limiting the current. So
Yeah, man, it's working phenomenally well with a potentiometer. Like, way better than this ever could with the regular resistor.
10K resistor across the gate and source to make sure the MOSFET is shutting off completely. And if you're using north and south, I understand you need to rectify the trigger coil.
Unfortunately, I've only got one. That's it right there for MOSFET transistors. The one that's in there right now. Tomorrow I'll have more coming in, and then I'll get even better ones coming in after that. But right now, this is the only one that I have. So if it's not working good, I can't do anything about it. I wish I could.
So, and Brandon here is saying you want to rectify the trigger AC pulse to DC to trigger the MOSFET. And I believe in the Bedini SG circuit, he has a, what do they call that? A diode from the emitter to the base that does that. And if you follow
that's right.
Right. So that should
It's a germanium diode. It's a Zener.
It's a that's the diode that does that, I believe, and it's called. He called it a. I forgot this. I forgot what it's called. A shunt or something like this. I forget what they call it. It'll come to me later.
The resistor, the big metal encased resistor, the shunt.
Well, that's for an amps meters and stuff.
Okay. Let me think here.
Snubber, I think it's called snubber diode or something.
I think I might have like some of them. I bought like one of the multi-pack of diode, and that's how I learned about
clamping diode. That's right, you got it. That's what it's called, Brandon. The clamping diode. That's what they call it. The clamping means to rectify AC, basically. And that's what Bedini called it too, but that's what they call it, in electronics. They call it a clamping diode.
So like this is a complete SSG circuit. Okay, so it's got the diode.
That's the K energy.
K energy dot store.
Yeah.
Beautiful circuit. So So it's got all
Tanner just got a
the
lot of good
trimming.
stuff on his story. I've seen all his builds are very nicely done.
Yeah, this is beautiful.
So, where are you going with it? I mean, do you want to automate the swap, or what are you thinking of doing here?
Yes, that's one thing that I wanted to do here, because right now, I gotta like swap 4 connections, make sure I don't get any of them wrong,
Well,
and
I
then
have
I
an
can
answer for that.
change it up right here. So I was thinking, in order to do that,
Well, don't think. I already did the thinking. Yeah, the
right
double
here.
pole, there you go. The double pole switch is what you need to do that, right? And you can do it slowly at a time with a timer, like you know that
I want to do it
remember that
fast.
diagram that we put together that you put together and I drew it out for you. That's one way to do it slowly.
But I can make that timer click at like 1 second pops, you know, even faster.
Right, but then again, you got to use power for that timer. But,
that's true. Oh wow! Right.
So the way I thought of doing it is, you know, is not really. I'm not really swapping the batteries. I'm just bouncing the flyback. To not swapping, instead I'm bouncing. So instead of using, I don't know how many coils you're going to use, but if you use 2 coils, you can bounce the flyback from the 2 coils between 2 batteries, and you don't have to swap anything. You just double pole switch each coil over each battery, and that's it. Let me bring that up. Hold on.
Now am I doing the coil? But I have 2 separate. I have 2 SSG circuits that I can use.
Well, I have a 13-minute video that I kind of tried to explain a way to bounce the flyback between 2 coils and 2 batteries, if you want to watch it.
Okay. I mean, can I use my SSGs in the circuit?
Well, it's not an SSG circuit per se, but it follows the concept of Bedini's method for capturing the flyback.
I got that.
With the diode arrangement, and it's a modification off the SSG design, but it's not the SSG. It's not anything like the SSG, but it's based off the Bedini's SG circuit and his concept with that circuit.
So hence, like, we need to make our list of what we need to make this work.
Right.
Yeah.
So, let me bring the video up and I'll mute the audio, or I can let it play, because I do explain in the video what's going on. But I can explain it live as well, if that's what you prefer.
Yeah, it'd be good.
And
been getting a lot of sun lately. How about you, Mike?
Me? No, I've
been inside.
It's super hot where I'm at. I don't know. I'm in Florida, so
yeah.
Right now,
at the pool. I've been at the pool myself, man, all the time.
What happened to? Where did it go? Give me a second here. There it is. Okay. Okay. So, okay. It's tough to explain what I'm trying to explain, but where is it? Oh, there it is.
Into the battery, and then you want to repeat this process over and over and over.
I remember
what you really
this
want
one.
to do is you want to go as fast as you can without a capacitor, for the simple fact is You want to put a lot of this radiant energy to the source.
Brandon, if you want to join, the link's in the chat.
Okay. Go back here a little bit.
More the merrier.
Talk about
Absolutely.
this image here.
There's a video playing for sure. We got that.
So in the Bedini, I'm going to compare this to the Bedini SG single drive coil, single trigger winding, bifilar. Okay. The bifilar, the trigger winding is not shown here, but make sure the audio is working. Okay, we're good. So the trigger winding is not here, but their drive coil is here, and there's 2 drive coils, not 1. And those are the 2 coils you see. Now, whatever method you use to trigger the source to energize the 2 coils is up to you. But you have to trigger both the positive and the negative from the source to those 2 drive coils. And that's a double pole switch method, positive and negative, both poles, double pole. And that's how you would energize the coil, however you do it. But you don't energize the 2 coils at the same time. You energize one at a time. And if I play the video, you'll see they don't switch together. So there might be a lot of confused minds out there as how this circuit is going to do that without shorting out. And I'll try to walk you guys through that right now. And let's go to the left side.
Okay, let me just say something real quick. I'm going to show another video of how.
I'm here.
I'm going to show how, and after this, another video, how if you single pole switch, even in this circuit or any other circuit, you single pole switch, the flyback will get it will get canceled, you know, and on the line, it will get canceled on the line, not on the battery. So.
Oh, I see. I hear you.
And I'll show that later, but let me continue this.
And you see the switches are closed on the source battery to the drive coil. There's 2 drive coils. So the left side source is now charging the left side drive coil, but the right side source is not doing anything, and it's being isolated from the left side by the diode, the high voltage diode, on the plus terminal of the right side battery. So in that method, you know, while the right side is open and the left side is closed, you isolate the right side portion of the circuit. So, and that right side is the right coil with and you can see the 2 lines, the 2 circuit lines heading to the left from the right side coil. And since the 2 switches underneath that coil are open, you don't really need to trace that at this time because there's nothing going on there, but you can trace the 2 lines from the right side coil, the 2 circuit lines, over to the left side. And one of those lines has a high voltage diode pointing to the positive terminal of the left side battery. So that diode, paying attention to that diode on the left, on the positive terminal of the left side battery, while in this action here, the left side is being switched from the source to the drive coil on top of it, you are connecting to the right side circuit, but the diode is isolating the right side from actually connecting to the left battery. And if anything's connected on the right side, it's the right side coil because the right side battery and its switches are open. And at the same time, you have the left side battery and its negative terminal going up to charge the negative side of the coil, and that line heading to the right, that circuit, has a diode facing the right side battery. So the right side battery plus cannot feed to the left by that diode blocks it. So the diode is blocking it's doing the isolation for you on this between the left and right side. Those two diodes are doing the isolation for you during the switching. And I'll explain that again. So when the right side is open on the two switches, right? So the coil don't get charged. But look at the diode; it's facing the plus terminal of the right side battery. So any positive potential coming out of that battery will be blocked, heading to the left. And that opens the circuit for the right side to the left.
All right, so I made a mistake there. I meant to say left side battery, but the diode facing the left side battery plus terminal is blocking the left side battery from charging the right side coil. And the diode facing the right side battery plus terminal is blocking the right side battery from charging the left side coil. But it's not blocking the flyback from coming from the left side coil. And the same thing for the right side coil. Its flyback can hit the left side battery. If that made any sense. I try. What I meant to say is the two coils are not feeding each coil is feeding. Okay, the left side coil is only flying back into the right side battery, and the right side coil is only flying back into the left side battery. And that's it. You there? Bale? Yeah.
So meaning that the right side has no connection to the left because of that diode. If the switch were closed, closed on the positive terminal of the right side battery, then I'll go to that position here. It's closed now. The right side battery is closed, and the plus terminal can go up to charge the coil, and the minus hence. And then look at the plus terminal of the right side battery going up to charge the coil, and you see that line going to the left, and it connects to the negative of the left side battery, which is not a problem, because it only is a problem if the right side negative is connected to the left side positive at that moment. And since the right side negative is heading over the top of the two coils, that line is going to the right, up top, over the two coils, coming down to the left side battery positive terminal, but the switch is open at that moment. So that's why the right side negative terminal of the battery cannot reach the left side positive terminal of the left battery, because the switch is open right now. But the right side positive terminal of the battery can reach the left side negative directly when the switch is closed on the right side, as it is now. Yeah, that is confusing. I'm just going to do it anyway and speak what I'm trying to see here, or what I see here, and why this works. And it took me a while to get this circuit right. Before, I had only one switch on each source to the coil above it, and that was not working out. It turned out the flyback rebound or whatever was being canceled on the line instead of over the battery terminals, which is what my goal was. And adding a second switch, double pole switching this, achieved that beautifully. And there's more than one way to do this with one battery and a single coil, and still do the capture of the flyback efficiently without canceling it on the line. and I have those methods on my channel as well. You know, there's more than one way to do this. I just like this one the most because how do I explain it? Other ways you can do it with a single battery, single coil, and you can energize the coil and have it fly back to the same battery with double pole switching and you know, the needed circuitry. Those methods are great. I like them. With that is, you know, the thing about that is, you know, the source is receiving charge right after it gave a load, and it's getting charged via the feedback, the flyback, feedback, whatever, and that's great. And you know, certain types of systems can handle that, like capacitors or whatever, or efficient electrolyte type dense batteries.
What's
But I
up?
don't think it's so good for lead acid. I don't think they can receive a charge so quick. And with this method, you can have one battery get loaded by a coil, and then you can unload that battery and that coil into a different battery, and that other battery to the right will be the ones that's not, at the time that it receives charge, it's not loading anything. That's why I like this. Well, the same thing with the single battery, single coil flyback, you know, is technically at the time that battery is being loaded, it's not receiving charge either, because, you know, it's just getting the charge a lot quicker after it's been loaded. With this circuit, you give it more time in between the two, in between the source and how long it takes for it to receive a charge from the flyback. You give the loaded battery more time after it's been loaded to receive charge with this circuit. And you can slow down the switching to a very low frequency. You just want to make sure that your duty cycle on each double pole switch, and by the way, there's 2 double pole switches here operating independently, one for each source to each coil, and you trigger them, stagger trigger them. But you could slow down that frequency, but just make sure your duty cycle is not very long, you know, because then you'll be wasting power. And that requires a special switching device. Maybe an Arduino can do that. I know an Arduino can do that, or an Lego can do that. You can set the duty cycle on that to, like, you know, 1 millisecond or whatever. Low, the impedance high, you keep the current low like that.
Yeah, I was just rambling there, but that's pretty much that's best as I could try to explain it. But yeah,
That's good.
so, and I'll show how if you single pole switch, the flyback will get canceled on the line here. Where is that one? Where is it? What's it called? Single battery. There it is. Okay.
Repeat this process over and over and over. But what you really want to do is you want to go as fast as you can without a capacitor, for the simple fact is you want to put a lot of this radiant energy to the source.
Okay.
So,
All right.
I want to go over this single battery. The Dini.
Bale.
Yeah, what's up?
So this is the way to do it with one battery and double pole switching. But
Okay.
But in the drawing, I'm going to remove the left switch. You see the one on the right and the one on the left?
Yeah.
I'm going to remove the left switch and show how when you single pole switch this, you lose the flyback on the wire instead of the battery. Okay?
Hmm.
Modification of the flyback capture system. Made a video about this a couple days ago. Here you have the correct version, and here you have the incorrect version. I would like to discuss.
You see that red arrow? It points to where the flyback shorts out on the line.
Or draw out here why it's, incorrect. And it's incorrect because it has only one switch on one side of the inductor, the negative side. And that's typically how you switch the Bedini SG monopole system, with a single switch on the negative of the battery or the source. Okay, this will not work because the flyback shorts itself out. Here you have the positive flyback, here you have the negative flyback.
Yeah, man.
Positive from your battery. It places a positive here and a negative here when it's charging the coil. Okay, when it's not charging the coil, the polarity inverts, the coil loses charge, drops its field, flies back in inverted polarity. The polarity you see here, plus and minus. And the reason why the flyback gets canceled in this circuit with only one switch on the negative leg of the battery is because when the positive flyback goes out this way, comes across this diode to this point here, the negative flyback meets the positive flyback at the same point, and it gets canceled.
And there you go. That's it right there. So we'll open up the discussion now.
Thanks, Mike. Appreciate that. Getting it all.
Did you see that?
Yeah.
Okay. So that's why you have to double pole switch.
Yeah. I mean, I got a, what do you call it? A latch double pull switch. I have two of them.
Yeah. So you have to add that second switch on the left there to avoid that canceling the flyback on the line. And it doesn't matter if you use the two coil circuit, or if you use this circuit, you still need to double pole switch, or the flyback will get canceled on the line and it won't hit the battery and you'll just be losing it. It won't stop the circuit from operating like a pulse motor, but you won't be able to recycle the flyback and it'll be less efficient.
Got it. So,
Brandon?
I mean, this one over here that I'm looking at right now, that's a 24 gauge coil with a 32 gauge trigger in it. So, since I'm running it on a reed switch, I could easily, run those two in series, the 24 and the 32. But this is it on 32 right here. This is max voltage. I'm at 31 volts. I'm pulling 50 milliamps, and it's going really fast. In my opinion, it's going like 1,800 RPMs. And then this one is doing all right. I mean, it is running on a power hungry coil.
Right. Yeah, I mean the Bedini SG is real fun to work with. You could, you get free rotations while you're just moving energy from one battery to the other. And in the whole time, you can be self-aware that the rotor is spinning for free.
Basically, but you do spend a little bit less than you put in. As long as you have somewhere to put it, then you're ahead. But if you don't, then you're losing out.
Brandon, you want to join in?
Because I've measured the input and the output here, and
Hello.
hello.
Hey, what's up, guys?
Hey, what's up, Brandon?
What's going on?
Hey, what's up, Bale? Mike?
How's it going?
I'm doing a little bit better now. I got actual house internet, which I don't have to worry about all the lagging like a long time ago. I'm sorry. Yeah, I was taking a little bit to get set up. I wanted to bring up a video from Energy from the Vacuum where Bedini addresses on the oscilloscope what happens when you use north-south magnets. And I'm trying to remember, I'm here looking at the Energy from the Vacuum videos on my computer. I just pulled them up. Let's see. It's the one where he's using that big window motor that he made, the black one. See, I'm fast forwarding through it. Let's see. It's not on this one. Yeah, I'll get it for you. Let me just find a timestamp of where he starts talking about it and the video, and then I'll find it on YouTube. But yeah, I'll go ahead for now. I'll pop back in as soon as I find it.
Okay. Yeah, man, I'm running 120, so I wouldn't be able to do north-south right now. But this one over here is it's actually on 90 degrees, so I can run a north-south on this one.
Okay. Nice.
But it is this is a reed switch right here.
Yeah. Okay. Yeah. Reed switch, you can do it.
What did you mean you couldn't run it north-south? What do you? I'm not following you there.
Well, like you wanted to use MOSFETs, right, Bale? You wanted to use MOSFETs, you were saying earlier, I think?
Yeah, I do want to learn how to use MOSFETs. I want to have a circuit that I can use MOSFETs with.
Yeah, I'm working on that right now myself for my generator circuit, but you remember the generator circuit, Mike? The shorting circuit that I had?
Yeah.
Remember I was talking about we couldn't get it working with north-south magnets? Well, I rectified the trigger coil, with a half wave and a full wave, and I was talking to ChatGPT too about these things, and it was verifying that I need to put a half wave or a full wave rectifier on the trigger coil to give it a consistent.
If it's a monopole, he has to use north only, right, or south only.
Well, like if he's using a monopole like normal Bedini, north or all south, you don't have to really rectify the trigger because it's all one pulse, the same polarity. But north south.
Now I get now I get it. Okay.
Like if he had 4 magnets, he's only going to be pulsing the 2 norths or whatever, or the 2 souths with the north-south setup. Because I've actually experienced that on my setup too, and any Bedini setup will act like that. That's why they came up with the Ron-Cole or the bipolar switching sequential circuit, because that actually did that in a more advanced way, I guess. Or like the Sky Collection circuit, I guess, does that, I think. where you have two
Sky Collector.
Darlington pair.
Speaking guy, right?
Yeah, he has a circuit that uses a MJL 21193. He uses a PNP and an MPN, one for
Okay.
each. But I don't think I don't remember if his is doing that. Like his circuit's pretty interesting. Like you don't even need a trigger circuit. It uses the power winding to charge up a capacitor, and that fires a transistor to fire the. It uses the same coil as a trigger.
You can't use a clamping diode with a north-south rotor?
Yeah, you can.
Okay. It would still work. Huh? That would be cool because then you can generate AC with a stator.
Right.
How would you do? You would have to. I guess you would use the clamping diode in two directions from the base to the emitter, huh? Two diodes.
Yeah, something like that. Yeah. Mm-hmm. That's what I was. I wish I had an oscilloscope, man. I have a little one. I finally got it to power on, but I'm gonna get a decent oscilloscope this year because I need to see the coils, like the waveforms of which way it's firing or how long and all that. Because I'm gonna have to look at that because I want to make sure that the MOSFET is turning off completely. That's another thing. And like my generator shorting circuit, I figured out that I needed to. It was a little bit of a learning curve trying to learn MOSFETs, and I'm still learning more about them because they're fired more with voltage than current. Like the transistor and Bedini setup, the trigger coil, you need about 1 to 5 volts to fire a transistor typically, right? And with some decent current behind it. And the more current you give the transistor to the base, the harder it fires. But a MOSFET's different. It'll fire really sharp on and off, and it can fire really fast. And all you need is a high, not a high voltage, like a really clean, stable voltage input. I mean, you don't really need a lot of current behind the voltage. So you can use like a really thin winding coil if you want, as long as it's enough voltage. And that's the beautiful part of the MOSFET versus a trigger from a transistor, because it doesn't cause too much drag. Because remember, the trigger coil in a Bedini setup is kind of like a generator coil, basically. And the more coils you start adding with more trigger coils is going to cause you a little bit more and losses with the drag.
Right. I mean, if the more current you have behind the base, the longer the duty cycle is.
Right. Am I still live? Can you hear me?
Yeah. No, you just had two. You joined twice. Yeah. So that's a lot of ways you could wire these things. Can you hear me? You there, Brandon?
Okay, yeah, I lost you for a second. I was watching the stream on my computer, but it.
Oh, I just kicked it. I thought you had joined twice by accident. Sorry. Go ahead and.
Oh no. How do I get back in? That's all right.
Yeah, there's a lot of ways you could wire up these circuits. A lot of things you can do.
Right.
I like the coil shorting idea. That's impressive.
Yeah, man.
Thanks,
I like
man. Yeah, I just moved to a new.
Myself. I've been telling my people, my buddy, just one buddy actually, about your stuff.
Thanks, man. I mean, it's open source. You are more than welcome to use it however you want. I mean, it's on my community post. I put it on my channel a while back, so y'all can build it.
I was telling him about it, but he actually mentioned it before you showed me that, like about a year earlier. He was talking about shorting coils.
It's been done before many times. Like Aaron Murakami have showed it. and energy science videos. Like it's not a new thing. And Robert Adams, a lot of people
Did you
were
ever
doing the
get a hold?
push.
Did he ever get a hold of you? Is what I was trying to get at.
Who are we talking about?
It's Peter Holofax X.
Oh, Peter Holofax. Yeah, we talk a lot.
Yeah, man, he's the one who brought it up like a year before you did. And I'm like, yeah, man, he's talking about it now too. And I was like, you probably talked to him about it. And it was weird because he probably been talking to me the whole time about it.
Yeah, I just think it's interesting, man. Like I'm fascinated by it because the Bedini motor doesn't have a lot of torque unless it's like a really big one, with multiple coils. But
Right.
but using the shorting coil method, you can get the
You don't
mechanical
need torque.
energy. Yeah, you can turn the mechanical energy into usable, output. Like making more back EMF off the generator coils. And that's what I wanted to do, and then put it into a cap dump and like put that back into the primary battery. Like I get 1-to-1 ratio. Huh?
Run this SSG off a single generator and a trick coil.
What is that?
SSG off a single generator and a trigger coil.
I can't hear it. The signal generator?
Yeah, I'm gonna use a signal generator
Okay.
and a coil. Well, here, I'll show you what I'm gonna do. Hold on. Can you see what I'm doing?
Okay, so you got a. Hey, I heard you earlier. You were talking. That's pretty beefy coil, and that's. What's that? Okay, you got a fan at the end. Is that just like a load?
Yeah, it's just like a scooping fan.
Okay. That's a good thing sometimes. Like like K-Energy and Bedini, they put fans on the Bedini motor purposely to slow down the speed, and you actually get a little bit more output.
Yeah, because you got to try a little bit harder, or is it just because the speed is slower?
I guess it delays like the timing somehow, or the way it's firing. I'm not sure. Like if you were looking at an oscilloscope, you probably could see that.
Oh, let's look.
Oh, cool.
I'm
My
on the
friend's
battery
here.
though.
My friend Shadowburn 3D. If y'all don't know him, he's here. That's pretty.
Yeah.
How's it
I like
going?
the new motors. New motors, shit. The opto-driven 0-point motor.
So what are you doing there, Bale? You just gotta get the SG motor going, the K Energy circuit, with the generator mode.
Yeah, he posted a video about that.
Yeah, that pot. I remember you talking about it. Those are nice, man. Like I have some of those, and it's hard to burn those out. That's a 25 watt, right?
Yeah.
That one. A 1K.
Your buddy's motor, I think, is like the awesomest thing I've ever seen. The 0-point motor.
Which one is that?
Oh no, you're talking about 3D PPM? Are you talking about redesign?
Both of those guys are awesome. I haven't seen redesign in a while.
Yeah.
I remember talking to
Redesign's
him
motor,
back
that's
then.
who it is, man. He's got an awesome motor out right now.
Which one? 3D redesign?
Redesign, yeah. 0-point opto driven.
Oh yeah. Is it the Zero Force one you're talking about?
Yeah,
I saw that one a while
motor
back.
is nice and clean, man. That's awesome.
Yeah, I talked to him about that a long time ago, like about making a toroidal, but I want to make a toroidal core Zero Force motor, like like you have to put a ring, like a toroidal ring with all the coils. His coils are separated. I think they're air cores, but you want to make it in a toroidal ring, and everything changes from there pretty much. And then you want to dual axial flux it. That's what I'm gonna do, which I haven't seen it done yet, but there's two.
Top and bottom, like side and side.
Yeah, but dual axial flux, toroidal core 0-force style Bedini motor. Wouldn't that be crazy?
Yeah.
Coil shorting is a different way of statoring without the need for torque, you know. I think it's way more efficient probably than a standard stator with AC north and south.
Do y'all know that guy Spencer from what is it? Limited Potential Energies? I think that's what his channel's called.
Sounds familiar.
He's replicating the 10 coiler Bedini motor, man. Like the 7 Filer coils, like 10 of them. He's
Right,
actually
right.
rebuilding it from scratch, really nicely.
A big one.
He's put a lot of money in it. Yeah, a big one.
10 7 filers.
And he's going to be using silicon carbide switching MOSFETs, like the newer types.
Oh,
Which is
I mean,
and he's going to use opto coupling, opto sensing discs to trigger it as well.
Will you be able? Will he be able to get around needing to match all those MOSFETs, or what?
I'm not sure. Yeah, I know you're supposed to match them and all that, but I mean, like Rick Friedrich has like a axial flux motor similar to what I'm wanting to do, right? And he had like a MOSFET driver. He had like one single MOSFET firing 8 coils, all 8 of or 4 of his motor coils. He can do 8 if he wanted to, because the MOSFETs can handle a lot of amperage versus, you know, the transistors, and they switch a lot faster. So it's actually cheaper if we can achieve that, you know, with MOSFETs. You don't have to worry about matching, because
you need to add diodes to those coils on that one MOSFET. Otherwise, the flyback from one coil will channel into the other.
Right. I mean, Rick Friedrich has some circuits that do that.
Oh, yeah?
I don't know if you've ever seen his motors, but he's got some pretty big motors. I mean, that they use MOSFETs or transistors, but yeah, you would want to match them.
You can't put a 7 filer in parallel across one transistor, because the flyback from one of those filers will feed into the other filer. Now, I don't think that's a problem, but it may, I don't know. I just think you need to put a diode on each filer to keep the flyback from one filer going into the other. And you know what I mean?
Yeah.
But
I'm looking
you
here.
could probably still do it without the diodes on each filer, but the flyback will probably bounce between all the filers before it heads out the single flyback diode. I don't know, just a theory. And what happens when you bounce the flyback between multiple filers within each filer? What happens to that signal? Does it stay? Does it get corrupted, or does it, because each filer has its own individual flyback signal.
I wanna bring up this clip from the energy from the vacuum. So I think I found it right here.
Put it in the chat.
Yeah, I've been going through these videos trying to find. I'm gonna mute myself for a second so I can listen to what they're saying real quick, and I'll be right back.
Okay.
Je te découvre encore, tissant nos douceurs. Dans cette ville, nous vibrons cœur à cœur. Toulouse, nos âmes dansent, épris de romance. Dans les ruelles, on explore, on avance. L'amour fleurit ici comme un doux printemps sous les lumières. Pour toi, je fredonne du Nougaro tout le temps. humaniste, toujours dans mes pensées. Un amour éternel que rien ne peut briser. Dans les rues de Toulouse, amour en fête. Des terrasses débordent de lumière secrète. Sur le pont de la Garonne, main dans la main, nous rions ensemble en ce doux matin. In the dark, where the shadows play, the beat drops heavy like night turns to day. Feel the bass pulse through the crowded space. Lose yourself.
We pull the energy out, and that's what we're tapping off of. It just looks like a normal circuit, except that it's one wire. We're getting the energy from one wire.
Okay.
We're not pulling it from the primary battery
Right.
at all.
And just to reiterate, which wire on the machine?
Okay?
I know we covered that earlier, but just
We're
to...
just using one of these wires here. This one wire. So we're using this as one wire, and this is one wire. Just one coil. Just like this. Just one wire.
Okay.
We're
Yeah.
across this one wire,
Right.
as we showed on the blackboard there.
Right.
So let's pull some energy from this at a 30 amp rate and see if it did put it back. Now we didn't give it any time, we just told it to move a certain, but you could see that it did charge it back up to that point.
While doing all that mechanical.
Yeah, while doing all that mechanical work. So we don't want to kill this battery. And then of course it recovers. Now if we leave the battery like this, in this condition, this is when it's going to highly sulfate up.
Right.
And that's what people basically do with batteries. They run them out until there's no more energy in them, and then they just, well, I'm going to charge it tomorrow or the next day. And they forget all about it, and then when they go to use the battery, it's sulfated and they can't do anything with it. This is the COIL window motor running with just one trigger magnet. Built big enough so that you can see the internal workings of it. This is the actual timing mechanism. You can see just one magnet going around, and it's alternating switching poles, because on the window motor you have north and south poles all the way around it. And we're using, once again, just one winding. And here's the only level that we can get out of the motor for recharge, but it's not good enough to charge a secondary battery, and I'm going to do that in a second here. I'm going to put a secondary battery here. And what I want to say is this battery recovered all by itself to 1275 after the negative charging. And now what we're trying to do is charge it with the back EMF. And we can see here that the back EMF is incapable of charging the battery, otherwise it'd be moving upward. And it's not. So what's this signal actually look like? And it's a very efficient motor. And we're just running it on one trigger.
Yeah, who is Cole?
Cole is a partner of mine that I knew from the audio days in our amplifier company.
Yourself in the rhythm, find your place. Euphoria is calling, bring the fire. Chase the night, let it take you higher. In the trance, we're all alive, aspire. Feel the rush, let the music flow. In this heartbeat, we let our spirits go. Lights are flashing, energy supreme. Riding waves of sound, lost in the dream. Every heartbeat syncs with the rolling tide. In this moment, let the music be our guide. Together we rise, no holding back. Chase the night, let it take you higher. In the trance, we're all alive as fire. Feel the rush, let the music flow. In this heartbeat, we let our spirits go. As the night fades, we leave our mark. In the echoes of sound, we find our spark. Leave my mark. We are we find our spark. In the club, the rhythm moves our feet. With every bass drop, we feel the heat. Strobe lights flicker, bodies in a trance. We're lost in the music, caught in the dance. Feel the vibe, let it take control. house beats, they move our souls. Lost in the sound, it makes us whole. Dance in the dark, let the night unfold. This is our anthem, let the story told. Tech house beats, they move house souls. Talent sound, let the story be told. Tech house beats, they move our souls. Lost in the sound, it makes us whole. Dance in the dark, let the night unfold. This is our anthem, let the story be told. As a knife basically holds on tight, Tech house forever will chase the night. Dans les rues de Toulouse, amour en fête, les terrasses débordent de lumière secrète. Sur le pont de la Garonne, main dans la main, nous rions ensemble dans ce doux matin. L'atmosphère légère comme un joli refrain. Toulouse, nos âmes dansent, épris de romance. Dans les ruelles, on explore, on avance. L'amour fleurit ici comme d'agréables printemps.
All right, guys. So
Sous les lumières pour
Bale got
tous
disconnected.
les nougats tout le temps. Les briques roses brillent sous le soleil, chaque regard échangé. Un
Or
trésor
he
sommeil.
bailed out. I guess that's why he named himself Bale.
Je te découvre encore, tissant nos
Oh,
douceurs.
that's funny.
Dans cette ville, nous vibrons cœur à cœur. Toulouse, nos
So
âmes
I'm going to play the rest of this, a little more of this
And
video.
so Ron Cole and myself developed these motors from a little prototype that I had. And Cole actually developed all the switching for the motor. But as you can see here, Cole calls it counter electromagnetic force. And you can see here, this isn't like the monopole at all. And that the back EMF is much lower than what the actual, these are the two poles switching. See, north and south. And then this is the back EMF that you're recovering in between. And so it's way below the battery voltage. So therefore, if you turn around and you look at this battery on the meter, it won't move. It's going to move. There's not enough there to keep recovering. What the battery is doing is, from the negative energy charge, it's recovering in itself that far.
And this is the same battery
That's the same battery.
we just used in the
We'll
previous.
pull it out again, and we can pull the energy out of it again. And you can see it's not moving up very good at all.
And the other battery over there next to the meter is the scope is just the trigger signal, right?
Yeah, that's just the trigger signal, and that's what you see right here. On, and the back EMF is in between here.
Right.
When it collapses, and you can see that when you use conventional circuitry, that you have just locked yourself in this loop,
Yeah.
and you can't get any energy out of this system, out of this coil. However, moving towards the window motor. If you were to run this on a monopole circuit, you could recover all kinds of energy out of this. In fact, we may set that up and show that.
Okay.
In a few minutes here. But we just want you to pay close attention that you would be waiting forever for this. This battery has recharged itself without the aid of this motor.
Right, since in the break that we took to
Yeah.
set this experiment up.
Right, which has been about, what, 3 minutes?
Yeah.
4 minutes. Okay, this battery just recovering itself from the negative energy charge. But it is totally useless. We'd have to have a 3-volt battery for this thing to do anything, and then it would load down the motor because it wouldn't be able to...
So what is the purpose of the window motor then?
Well, the window motor is a high torque motor and a very efficient motor. But I want to use it as an example here of showing that it's impossible when you have this closed loop system. All free energy systems are open to nature, meaning there's some place that nature can put its energy into. This is incapable of doing that the way the circuitry is. It's closed loop.
Right.
So nothing can enter the system.
L'amour fleurit ici comme un doux printemps sous les lumières. Pour toi je fredonne une nougat.
All right, folks. Ending the stream. Till next time.